Okay, so separating mixtures. There are various techniques for separating mixtures, and it depends on the type of mixture that needs to be separated as to what you need to use. You may well have seen this before. This is Rocksalt, and you may have used this in different schools as part of separation, but I'm going to use it today because it helps us to illustrate various different techniques. So Rocksalt, importantly, looks like this. It comes out of the ground, basically, and it's a mixture of soluble salt, sodium chloride, like we used when we made the salt solution. That bit's soluble, and a whole heap of clay, silicon dioxide, other bits of the rock, which are insoluble. So the techniques to use today is how to separate soluble solids from insoluble solids, but we have to go via solutions in order to do that. So the first thing we're going to do is just take this rock salt and grind it up using a pestle and mortar, just like this, just to give it a bit more chance in this dissolving. So you might want to consider, why does it grinding this up improves the dissolving? Think about that now. So grinding up any solid like that helps to increase its surface area. Now if you imagine that I was going to treat you at Christmas time to 3 chemistry textbooks like these ones here. If I wanted to wrap up these chemistry textbooks, I could choose to do it as all 3 items. Or I could choose to do it as 3 individuals, so that you thought you were getting 3 exciting chemistry textbooks instead of just the same one over and over. If I was to wrap them all together like so, imagine how much wrapping paper I'd need compared with wrapping them individually. So which ones would need more wrapping paper? So hopefully you got the idea that if I do them individually, I need more wrapping paper, because if I put them all together, I've got the top surface, the bottom surface, each of each sides, that's everything. Whereas if I take them and do them separately, I've got another bottom surface and another top surface to think about, and again and again. So in general, grinding up any solid into a powder like this one here increases the surface area, which then helps to increase how quickly I can get this stuff to dissolve. Here I've got some hot water. It's hot distilled water, heated it up on a tripod and gauze a little earlier. I'm going to add some of that into this beaker and give it a stir. To suggest why I'm using hot water instead of cold water. So there's 2 reasons why I might choose to use hot water instead of cold water. The first reason is that in hot water, the particles are moving more quickly, and therefore they collide more frequently, and therefore they cause the soluble part of the rock salt to dissolve more rapidly. And the second reason is, with hot water, the solubility of the salt increases, so I get more of the salt to dissolve in the same volume, so a higher concentration of the salt is produced. Just give that a good stir like so. Okay, now the first thing I'm going to show you is decanting as a separation technique. So decanting is great if you wish to separate big bits of insoluble solid from a solution. So how to do this? I've got another clean beaker here. I'm going to just use this stirring rod to just help to try to catch any of the bits that go into this. I'm just going to pour it in like so. So I'm decanting this across just like that. Now, by decanting, I've separated out these huge bits of solid quite nicely. But the problem is, I've still got all these other little bits of solid in there. How can I tell that there's still little bits of solid in there? Well, if you look at this is not a solution because it's cloudy. It's not transparent. And the reason it's cloudy is those little bits of solid that are still floating around in there in a suspension are bouncing off the light so that it looks cloudy. Whereas a true solution looks clear. It might be colourless as well, or it might be colourful, but it would look see-through, and this one doesn't. So I need a second method to separate the insoluble solid from the solution. Just to recap, inside here we had some soluble solid and some insoluble solid. So I added some solvent, some water, to make a solution of the soluble solids. The solution then was mixed with insoluble solids, some big bits and some small bits. The big pieces of insoluble solid separated by decanting, and the small pieces of insoluble solid I'm about to separate using the technique called filtration. perhaps you could have a go, whilst this is working, at drawing the diagram, using a really good science diagram. So 2 dimensions, please, pencil and ruler. Have a go at drawing a diagram of filtration, because this is going to take a little while to work. I'm just going to fold the filter paper in half, and in half again, and make it into a little cone like so. Pop that into the funnel, and just carefully pour that mixture into the funnel. And what we should start to see coming out of the funnel at the bottom is the filtrate, which is now see-through, so it's transparent or clear, and it is also colourless. You go and have a go at that diagram, make sure it's labelled properly, and I will continue to filter this mixture.